Alright everyone, we're getting ready for in-class assessment number 1, and here's the practice problem. Hopefully you were able to complete it, but I wanted to record this to show you step by step how you would if you got confused. So we'll just go through this step by step and show you how to get 100 on this. So we have two sensors here, one that's working and one that's not. And the first thing we're going to do, step 1, open our data file, Foxtrot versus Yankee in Excel, and separate it into two columns. So what I'm going to do is I'm going to take Foxtrot versus Yankee. I have it in a folder here, and I'm just going to drag it into Excel. It opens up a new Excel file, which is fine, and right away I can see the problem is everything is in the A column. I need to split this up. So you have to know how to do this. We're going to use our trusty text to columns tool. So in data, text to columns, and remember you get two options, and clearly we can see that we want a separation at the semicolon. So I'm going to choose my delimited option and select semicolon, and it will split this data up into two columns, which is what I want. I'm also going to expand row 1, select all of that row, and right click format the cells, and hopefully you remember this, how to wrap the text so I can see everything. And I will even be nice and center justify. Okay, so on the left I have the broken temperature sensors readings, and that always seems to be higher than the actual temperature reading. So we have the ability to link these. So that, but that's step 1, so I got 5 points. Step 2 is plot the actual temperature, which is in B column, versus the broken temperature in A column. So I can just select these both and insert a scatter plot. Remember, you'd really want to choose the scatter with no lines, because there's nothing really connecting each of these rows. We wouldn't want to connect the dots because there's no implied connection. So when we do that, we get something that definitely looks like a trend. Since it's concave up, it looks like there's more error. And so I am going to do step number 3. Step number 3. This is the key step here. I need to add a trend line and figure out what is the mathematical nature of this relationship. So right click add a trend line. And here's all my options. So I need to display the equation in the r squared value if I want to make a decision on which one is the best fit. And I'll make that a little bigger for the studio audience here. All right, so if I right click, format this trend line, let's take a look at my options. The exponential gives me a really good r squared value. Remember, the r squared value is a value between 0 and 1, where 1 is a perfect fit and 0 pretty much sucks. So I've got 99.4. The linear isn't bad, but it's less polynomial, and I'm looking at the instructions, and that's logarithmic. That's not going to work too well. Polynomial, I could, of course, set this order up to like 6, 7, 8, and of course it's going to get better and better, but I'm looking at the instructions and it says nothing greater than 2. So when I'm at 2, it's still high, but not as high as my exponential. Power, still lower. So it looks like exponential gives me my best r squared value, so I'm going to call this an exponential relationship between the broken temperature and the actual temperature. That is step 3. I got 10 points for that. Step 4 is to move this into a new worksheet. So I'm going to add a new worksheet here. I'm going to give it a label, actual versus Foxtrot temperatures. So I'm just going to cut and paste this plot into worksheet number 2, and it says format it so it's perfect. Okay, so we can do that. So that means I got a title, but I'm going to go to design. I'm going to add and get axis titles, primary horizontal title, primary vertical title, and those will both work really well. I'll probably want to make these fonts bigger. On the x-axis, I have Foxtrot temperatures, and I want a degree Celsius. I don't think we talked about this, but most of you probably know that to get a degree symbol, you go to Insert, Symbol, and you get a whole library of symbols. If you can't find what you're looking for, you might want to change the font. I was just using degrees, so it's the last one up there. Going to insert that, degrees Celsius. And on the y-axis here, I have actual temperature. And maybe I can get away with just copying and pasting my degrees Celsius. All right. I want to make these fonts bigger because the instructions say to make this perfect, and that includes addressing items, issues of readability. So that's looking pretty good. Last thing I want to do, two things. I want to change this title. So this will be actual temperature versus Foxtrot temperature for test data, being as descriptive as possible. I will make that font a little bigger so it doesn't look strange when compared to my axes. And remember, if you run out of room, you can adjust the chart area and move things around. What we're going for here is maximum readability. Okay, last thing here is fix my my min and max values. I have way too much leading x here. So right click the x axis, and I don't need to start at 0. I could start at 100, it looks like, and go to, how's 200 work? Oh, that works pretty well. And my major units look like they're working well in tens here. What about my y-axis? I think I can format my y-axis, and that really doesn't need to start at 100. It can start at 0. It could probably start at 100. Let's take a look at that. If you want to give yourself some lead in, then maybe say like 80 to 220. And yeah, that's a nice window. Remember, you don't need a legend here because there's only one data set, so a legend would be totally redundant. So the X here would be the Foxtrot temperature, so you plug in a Foxtrot temperature, and what will come out, what the Y value is the actual temperature. You could even replace the Y with actual temperature in degrees Celsius. So maybe I'll cut and paste a degrees Celsius. All right, that's 10 points. So I'm doing excellently. I am on step number 5. So step number 5 includes adding a third and last worksheet here, and this is going to be data from October 25th, 1985, an important day in pop culture history. And so that's my other file here. I've got some data that Foxtrot took on this date. Obviously it's going to be wrong. It's going to be too high. And now I have a relationship to tell me how much it's too high. So let's take a look. I'm going to drag this into Excel. And I can see I've got two problems here. So one problem is that all my data is here in cell A1, so I need to split it up. So you're thinking text to columns, but then also clearly I have one big row, and I will want this in columns, in one column. So I'll need to transpose this. So let's do those one at a time. First things first, let's split this up, and it looks like commas are dividing where I want cell divisions. So I'll go to data, text to columns, and delimited, and it's not the semicolon here, it's the comma that needs to separate everything. So there we go. And yeah, the last step, I want to turn this one row into one column. So what I'm going to do, if I scroll to the right, I can see this goes all the way to BXX. Pretty cool cell address. So I'm going to select that last cell. I'm going to go to the left, and I'm going to hold down Shift on a Windows computer, and that'll select all my data. Remember how to do this? I'm going to access the paste special function. So I'm going to copy that, Control C, or your favorite way of copying, and maybe I'll do this on another sheet. So add another sheet and go to Home. I'm not going to paste, I'm going to go to Paste Special, and you'll remember, hopefully you'll remember, that you get the little transpose option. That transpose just means turning rows into columns and columns into rows, and that works really well. So I can just copy this and paste it where I wanted, which was this original worksheet, so the third worksheet there. All right, so those are temperatures, but those are incorrect temperatures. This is the Foxtrot temperatures, and the last item here, number 6, is going to be to calculate a corrected temperature. So before I do that, let me insert a header row. So I'm going to right click on Windows, insert, and this will be Foxtrot temperatures, and that's degrees. So go to my symbols, get a degree, Celsius, and once again I'm going to expand row 1, right click, format that so it wraps, and maybe even be nice and center justify. Okay, so those are my Foxtrot temperatures. They're too high, so this will be corrected temperatures, degrees Celsius, which I'm going to just copy and paste, which is probably more work than just inserting, but I'm feeling selectively lazy. Okay, perfect. The last step here, the key step, the thing that you really want to understand is how this equation is useful. It's telling me how I go from plugging in a Foxtrot temperature for X to spitting out an actual temperature, which is exactly what I want in this scenario. I am going to go to this formula, I'm going to copy it, and this is what I want to insert for my formula here. Because I have a Foxtrot temperature, I need to plug that in. The thing is, there's a few things I need to adjust here. So it's 49.22 times E to the 0.0067 times X power. So first things first, it's not X. The X in question is on the plot it was the X-axis. Here it's the Foxtrot temperature for that reading. So I'm just going to select A2. The last thing is, how do I get an E? In Excel, E, the exponential, you can't just type in E. It's the exponential function. It's really easy. You just type in EXP, and then whatever you want to take the exponential of in parentheses. So if you did not know that, if you did not know how to write a formula with exponential in there, you could always look it up here or look it up online. That kind of reference is really easy. It's going to tell me about a problem I have, and that problem is that I forgot my multiply right here. And there we go. I feel good about this because I know the Foxtrot temperatures are too high and my corrected temperature is somewhat lower. So I'm going to call that good. I'm going to smart drag. And remember, you can physically smart drag, or the super shortcut is just if you can hover right over this box, you double click it and it'll smart drag down as far as it sees adjacent cells all the way down. So I have my corrected temperatures. I could correct any data temperatures I had for Foxtrot here, and that is the purpose of a trend line. You're finding a mathematical trend, in the form of an equation that you can then use to project other data. And I'm pretty confident in this trend line because it's got a very high R-square value that is almost 1.0. Step number 7 is just to submit this, or save this. You wouldn't submit it because it's just practice, but you'll submit it when you do the assessment. If you can do this, you're in good shape. Okay, thanks, bye.